In this question, we want to list the values of x for which f has a local maximum, and what are these local maxima, if they exist. So I'm looking at the graph and trying to determine if I have any local maximum. And what I'm looking for are changes in the graphs increasing and decreasing. So let's take a moment to look at this function overall and decide where the function is increasing and decreasing. So I'm going to trace the graph going from left to right. And as I trace along this section, I notice that the y values are decreasing. So let me label this section of the graph is decreasing. At this point, the y values are now increasing. And then it switches again to decreasing. And then it switches again to increasing. And then it switches one more time to decreasing. When I'm looking for a local maximum, maximum meaning highest or largest, I'm looking for the places when the graph changes from increasing to decreasing. If it changes from increasing to decreasing, it creates a peak, which is a maximum, a local maximum. And that's happening in a few places along this graph. Right here, we see a change from increasing to decreasing, which creates a local maximum. And here's another point where the graph changes from increasing to decreasing, creating that little peak. Now we notice that these two peaks are not the highest y values of the graph. We notice that all of these y values are larger. Even though they're larger, the word local is allowing us to narrow our focus to a localized area. So if we were to focus on only this portion of the graph, we notice that we do have a maximum in that localized region, and the same goes with this region here. In this localized region, we do have a maximum value. And so that's why we preface the word maximum with local. It may not be the maximum of the whole graph, but in a localized area, it's the maximum. So let's take note of the ordered pairs where we have these local maximum. This first ordered pair is -1, 1, and the second ordered pair is 3, 1. So our function has local maximum at x equals -1 and 3, and the local maximum refers to the y, the actual largest y value in that localized area, and that is 1 for both ordered pairs. So we have two localized maximum at x equals -1 and 3, and the local maxima is 1. Thank you for checking out my videos. Have a great day.